Hello guys, so in this lesson we're going to learn about multiply polynomial expressions, and we can multiply polynomial expression either by using distributive property or by using something that I used to call the box method. So in our objective we're going to write that by the end of the lesson we will be able to multiply polynomial expressions by using distributive property and or, so it depends, we can use either both or one of them, the box method. Okay. Alright, so remember, polynomial is represented by many monomial. Each monomial is a term made up by variables and coefficient. The coefficients are the number in front. So here, in this specific example, we want to write the area for this swimming pool. We have an expression for the width. We have an expression for the length. Now the width is a second degree polynomial because the largest degree is a 2 and the leading coefficient of 1, because if we only have x squared we have a 1x squared. The length is also a second degree polynomial and the leading coefficient, which is equal to 2. So when we multiply length by width in order to find the area of the swimming pool, we're going to find an area which is represented by polynomial expression of degree 4, because width and length, they both have a degree 2. So when we multiply, we're going to adapt these exponents so we get a polynomial expression of degree 4. Okay, so we want to multiply, so to find the area, we want to multiply length by width. The length is given by this expression, which is a polynomial made up of 3 terms, also called trinomial. So 2x squared minus 3x plus 1. And we want to multiply this by the width, which is a polynomial expression of degree 2. And this is a binomial because made up by 2 terms. Okay, so you can use distributive property. With distributive property, what you do is you multiply 2x squared by x squared, 2x squared by negative 1, and you get 2 terms out of this. Then you multiply negative 3x by x squared, negative 3x by negative 1, and finally you multiply this one by x squared and then 1 by negative 1. But in my experience, I noticed that the students usually prefer to draw a box and multiply these expressions. Now this box is going to be made up by, so we have a 3, we're going to make a 3 columns and 2 rows because it's a 3 by 2 polynomial. You can also make a 3 rows and 2 columns, it doesn't matter, okay, but you make a 3 by 2 box. Okay, so what we write on one side of this box? Well, one polynomial expression is 2x squared minus 3x and then plus 1. And we want to multiply this by x squared minus 1. I'm going to write this on the side. Now what we do is we multiply each term. So x squared times 2x squared would be 2x to the power of 4 because we are going to adapt the exponents. 2 plus 2 is 4. X squared times negative 3x is a negative 3x cubed. And then x squared times 1 is going to be 1x squared. And then I need to multiply the negative 1. So multiply the polynomial expression by negative 1 substantially mean to, it means to change the sign to these three terms. So negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 3x is positive 3x. And negative 1 times positive 1 is negative 1. So we would have get the same terms. We could get the same terms if we use just distributive property. Okay, so now we're going to combine the terms. So let's start with the 2x to the power of 4. Notice how this term is by itself. So it's going to stay. So 2x to the power of 4. Then we have negative 3x cubed. This is by itself. So it's going to stay. And then we have x squared and negative 2x squared. So these two can be combined together. So negative 2x squared and x squared. So this adapt to negative 1x squared, or just negative x squared. 3x is by itself, so we write it down. And then negative 1 is by itself, so we need to write it down, minus 1. So that's the expression for the area of the swimming pool. And notice how we get a polynomial expression of degree 4 and leading coefficient equal to 2. Okay, so here is another example. In this case, we multiply two polynomial expression, still of degree 2, but the first polynomial expression is made, both polynomial expressions are made up by three terms, so these are two trinomial. So we're going to make a square in this case, a 3 by 3 box. Okay, so on one side, we're going to write 6n squared minus 6n minus 5. On the other side, we're going to write 7n squared plus 6n minus 5. Okay. All right. So now we multiply these two expressions. 7 times 6 is 42. N to the power of 4. 7n squared times negative 6n is negative 42 n to the power of 3. 7n squared times negative 5 is negative 35 n squared. And then 6n times 6n squared is 36 n cubed. 6n times negative 6n is negative 36 n squared. And 6n times negative 5 is negative 30 n. Now we multiply the negative 5. Negative 5 times 6 is negative 30 n squared. Negative 5 times negative 6n is positive 30n. And then negative 5 times negative 5 is positive 25. So the 42n to the power of 4 is by itself, so it stays. Negative 42n cubed and 36n cubed can be combined into negative 6 n cubed, negative 35n squared, negative 36n squared, and negative 30n squared. They can all be combined into negative 101 n squared. And then this negative 30n and this positive 30n, they just cancel out because they're opposite. And then we are left with 25. So we get a polynomial expression of degree 4 with a leading coefficient, which is 42. Okay, so let me show you some additional examples. Alright, so one example I want to show you is number 6. Okay, so here we have a 2r minus 1 to the power of cube. So ask yourself, what does it mean to multiply, to raise something, to raise an expression to the power of 3? Well, this means multiply 2r minus 1 by itself 3 times. So this is equivalent to 2r minus 1 times the same thing, 2r minus 1 twice, so that's going to be the square. And then if you want to find the cube, you still need to multiply by 2r minus 1 for a third time. How would you approach this problem? Well, something we can do, since we have a product of 3 terms, so we cannot make a single box in this case. What we're going to do instead is to focused our attention to the first two terms, so any two terms, they're all the same, right? And the answer we get from here is going to be multiplied by 2r minus 1. So this means we need to repeat this process at least one time, right? So what we do is we make a box, a square, 2 by 2. We focus only on the first two terms. So the first two terms are 2r minus 1 and 2r minus 1. Then we multiply this, so we get 4r squared. 2r minus times negative 1 is a negative 2r. Negative 1 times 2r is negative 2r. And negative 1 times negative 1 is positive 1. Now, 4r squared is going to stay. Negative 2r and negative 2r can be combined to negative 4r. And then 1, we stay, so plus 1. Okay? Alright, so at this point, we have three terms, right? We got this, and we need to multiply this, so put in parentheses by, again, 2r minus 1. So we're going to draw another box, and this box is going to have a dimension 3 by 2 in this case. So one expression is 4r squared, negative 4r, and plus 1. And then here I have 2r minus 1. Now we can multiply. 2r times 4r squared is 8r cubed. 2r times negative 4r is negative 8r. 2r times 1 is 2r. Negative 1 times 4r squared is negative 4r squared. Negative 1 times negative 4r is positive 4r. And negative 1 times 1 is negative 1. So let's see what we get from here. 8r cubed is going to stay. So I'm going to write the answer here. Okay, so we get 8r cubed. Negative, oh, sorry, I made a mistake. This is a square, clearly, because it's 2r times negative 4r is negative 8r squared. So negative 8r squared and negative 4r squared add up to negative 12r squared. 2r and 4r can be combined into 6r, and then negative 1 is going to stay. So we get the polynomial expression of degree 3, because we're multiplying 3 binomial expression of degree 1, and since we adapt the exponents, we get a degree 3 polynomial with a leading coefficient which is equal to 8.